TuplOS. What is TuplOS, and first of all, what is the goal that we are pursuing within Tuple? The problem that we are trying to solve, as I mentioned before, is there is a lot of automation that needs to happen in the operator side, when you start to think about all these automation use cases, this can be in the hundreds. So how can you build a system that can bring to life these hundreds use cases in a way that can do very complex correlation and complex decision making, but also that is scalable and that is easy to maintain. So these are kind of the guiding lights for everything we do in our design. This is something that I came across actually a few years after I started the company, and it's a white paper by Google. And I'm putting it here because it actually reflects very well our approach. And I actually wrote a white paper also in 2018. You can find it in our website that discusses challenges of operational AI. But what this white paper, which I recommend that you read, comes to say is that ML is a great technology, as we actually can testify, but it is just a very small piece of a very complex puzzle. And in order for ML to make sense in an operational environment, you have to develop a lot of systems around this ML. And you have to consider, when you are building your systems, things like continuous operation, scalability, security, high availability, maintainability, right? Those are key things to, that you don't consider when you are building, Python code as a POC, but when you have to put something in production in a way that, can handle, terabytes of data, of workloads, needs to be fast, needs to be secure, you cannot be providing data to the wrong person and so on and so forth. You have to have many, many considerations that are beyond pure machine learning. And this is what we have created as a platform. This is what we call TuplOS, and the name TuplOS is because we always make the similarity with an operating system. It kind of hides the complexity of all the technologies that we leverage in order to offer high-value services to the upper layers and to build the automation. So this system is intended to handle the end-to-end aspects of an automation application in a distributed system. It handles the deployment and everything related to the infrastructure and services that are running on the cluster. It handles the data collection and transformation, everything related to the logic and the decision making using ML, plus then the following parts, which are what to do about the decisions that are done, what is the workflow, how do you handle these decisions, and how do you orchestrate it. And last but not least, how do you represent this in a user interface so that you can see the information, you can explore the details, you can train the system, provide feedback, and so on and so forth. So these are kind of the three layers of the platform, an infrastructure layer, a data layer, and a user interface layer. And this is all done to facilitate the creation of these automation applications. The idea is that we use ML to speed up the development and to simplify the maintenance. And we will go into details about how we do this. And another key principle of this platform is that this is designed to use as very little code as possible. So, ultimately, the domain experts can use the system. You don't need to be a developer. You don't need to be a data scientist to be able to create value on top of the platform. So when you look at what Google said and what we have built, there is a pretty much a perfect mapping. And the funny thing is that now there is a concept that is called MLOps. You can, you're following the trends in AI. This is really what is it about. It's about building AI systems in an operational manner. It's not just about doing an R&D exercise, but getting this AI to work continuously, to be able to be updated, and to be able to be continuously improved. So what are the approach that we have taken? The first one is, we have focused on the pain points. Where are the pain points? The pain points is really not so much on the algorithms. The pain points is on the tremendous amount of data that lies in the system. How can you bring data from multiple different systems? How can you correlate this data into a way that makes sense? How can you simplify and reduce the dimensionality of this data in order to make decisions that can converge? And how can you keep a system that is continuously changing? So these are, the key pain points that we have been focusing on when building the platform. The other thing is that we are very pragmatic in the use of technology. For us, technology for the sake of it is not the right way of using technology. We use technology to solve a problem. So we always use the simplest way to resolve the problem. Some cases that would mean using very simplistic rules. Some other cases we will use traditional ML systems. Some other cases we will use deep learning. So really, depending on the nature of the problem, we will apply the right methodology. The goal is always to provide the right functionality as fast as possible in a way that is maintainable. Okay. So how then, how do we build the systems? The first one is, we simplify the data acquisition. Then we use expert knowledge to try and reduce the dimensions as much as possible using known facts, so we don't have to reinvent the wheel. And then finally, we let the expert drive the system into the conclusions. But the funny thing is that when you look into the trending topics in the AI industry, there are these concepts that are actually, very key concepts of what our platform is. So we discussed already MLOps, but also very important thing is openness. So our system is fully open. It's not a black box. You can create your elements within it. You can create your own models. You can create your features and so on. You don't have to use code. You can use our UI utilities to develop that. And also we have data synthesis or simulation components embedded into the ML toolkit, so that we can facilitate the training of the system when there is not enough data. So, something to maybe browse later, and I will be happy to entertain later discussions if anybody has any questions. Some key components that I wanted to highlight. And there are many different engines as I showed here in this box on the right side. But for you to understand kind of the flow, we typically get data from the systems, and we calculate certain metrics. For this, we have a utility that we call KPI engine, and this is a editor-based solution where you can create different complex formulas that can aggregate data at different levels, and then this can be then used as an input to other data streams. One level of complexity beyond that is the feature engine and the corresponding editor, where you can mix multiple data sources and different logics to capture engineering expertise into into data points that are well known. And then these features can be used as inputs to the toolkit. You can also feed KPIs directly into the toolkit, but typically going through a feature phase is going to help you converge much faster. As I explained before, the amount of data that we have at the input is so large, and the root causes that we have is so big that if you don't simplify the problem, you're going to have a massive problem to try to have a good accuracy in your models. So therefore, we apply this simplification stage to reduce the dimensions and to make sure that we have a good accuracy because we are kind of focusing on what's really important. Finally, on the ML toolkit, we have different components, all integrated within this set of utilities that help you to analyze the data using unsupervised ML, for example, to cluster the different problems together and identify issues that are similar in nature, and then supervise machine learning techniques to do classification or regression, for example, for forecasting and so on. One other important aspect of how we work, and this has been very successful as I explained before, and as you have witnessed over these years, is that because the platform is very flexible and you can continuously update it, we don't intend to boil the ocean from the beginning. So whenever you have a problem, we start small, we start integrating a few data sources to provide a first set of resolutions. And then we build on top of that by integrating additional data sources that may be required to drill down into the problem, or providing further categories within the model or creating new features and so on. Because we have UI-based utilities for each of these steps, we can easily go through this cycle very quickly, and then that will, make you go over this line where you are increasing the level of automation little by little. Another important aspect that the system allows is to go from supervised mode or open loop to closed loop, basically, where you can put both the decisions and the actions in open loop until you have enough trust that the system is doing the right thing, and then you can put the decisions in closed loop, and then when you verify that the actions are right, you can even put the actions in closed loop. There are many actions that are done automatically today, especially in the proactive side of the house. Whenever we detect issues at the customer level, we quickly go and fix it so that we are preventing calls into customer care. So this is the typical way where how this works. So going back to the platform and how we use it in the different tools, we basically use these services to develop different applications. We work in different domains, mostly radio, but we are also going into the transport and the core. And then apart from the telco space, we are also using this same platform to develop applications in other industries. For example, for digital agriculture, for healthcare, etc. Because at the end of the day, it's all about automation. It's all about data-driven decision making, and the same principles can be applied. So to summarize, what are the key benefits of this TuplOS ML platform is the simplicity to ingest data and to correlate different data sets, the simplicity to create decision making utilizing ML by non-data scientists, the flexibility to create your own UI views and to customize them, and very importantly, that an aspect that many times goes unnoticed is the maintainability. So The system includes a lot of different components to make sure that it is scaling, it is well monitored and performing. It has a lot of self-healing capabilities underneath, and that it can be extended in a simple way, so it doesn't become a maintenance nightmare in the future.